Thank you for joining us today to this webinar for telecom operators. It's about preventing revenue leakage. We're going to talk about core versus intelligent network reconciliation. The speakers are Mr. Yasin Nasri, our product manager and CEO of Synaptic, and our data scientist, Salwa Shleili. Before doesn't know who is the host of this webinar, which is Synaptic. We are a data partner for telecom operators and the regulators. We provide data solutions based on machine learning. We provide data solutions for fraud monitoring, mainly sandbox, waggery, cellular fraud, for revenue assurance monitoring, for quality of service monitoring, and mobile money monitoring. If you want to have more information about Synaptic, about the solution we provide, we just send me an email. I'm going to share with you the detailed brochures of each solution. I think without further ado, I have to let our speakers start the session. Salwa, you can take the lead and start the session.
The topic of our webinar is revenue leakage, which I think is a critical issue for telecom operators that does not have or get enough attention. If you are wondering what is revenue leakage, to put it simply, it's the money that the company, in our case, telecom operators, should get, but they don't. And the causes for this might be surprising. Taken, for example, billing errors. Imagine a customer that makes a call or take advantage of a service, but this service is not tracked properly. It is miscalculated, or even worse, it's not recorded at all. This is money lost. If you think like 2 errors like this or few errors like this, it's not a big deal. But if you multiply it by millions of customers, the price will snowball very quickly. There is also fraudulent activity. Someone finds a loophole in the system and start to use services for free, like international calls for free. That's also money lost. And it is also frustrating because you have someone taking advantage of your system. An important cause also is roaming. Telecom operators rely on partnership to handle customers when they are traveling. But what happens when you don't track that or the use of this service or this data properly? That's also money lost. There is also regulatory compliance. Telecom operators should follow strict rules, and when they don't, they will pay massive fines sometimes. That's also money lost. Revenue leakage is not a small problem. Statistics shows that it's usually between 100% and 5% of total revenue. If we take, for example, a company that makes $10 billion a year, that's $100 million gone and lost. The impact of revenue leakage, it's not only financial. There is operational impact. Just imagine the amount of resources and cost that you should use to find the leakage and then handle it. There is also an impact of the reputation of the company. If you are a customer and then you get a billing that is incorrect, you don't say, oh, I lost trust in the billing system. You lose trust in the whole company. There is also regulatory impact. When a telecom operator does not respect the billing standards, it might get huge bills, and that's a hit that a telecom operator should not have and doesn't like to have. There is also a strategic impact. If you have revenue leaking out of your system, you are left with few resources to invest into your future growth and innovation. So revenue leakage is not only about today's loss, it's also about the future's missing opportunities. In today's webinar, we will be focusing on one of the most contributors to revenue leakage, which is billing errors. The causes for billing errors is a mix of everything, of a lot of things. Taking, for example, the complex billing system for telecom operators. Telecom operators handles a variety of plans and bundles and promotions, and to track all of this and handle it very accurately is a challenge. There is also data. Data might be inaccurate. We might have missing information. This gives also error and challenge to get a precise billing. If you add to that the volume of data, if you even make a small error, that will grow into massive loss very quickly. To all of this, also it adds the real-time challenge. Operators handles the calls, SMS, and data in real-time transactions. So to make sure that everything is handled properly, very quickly, give a little margin to error, little margin to correct the errors if they happen. As a prevention to billing errors, we should reconcile data between two systems, the core network and the intelligent network. At the heart of the core network, we find a lot of key elements that interact with each other to make things run smoothly. We find, for example, the MS-C, which is the mobile switching centers that handles voice and SMS. We also find SGSN that handles data. All these elements track the use of services and generate records of it. We also find the intelligent network, which manages advanced services. And within it, we find the OCS, which stands for Online Charging System. This OCS handles billing at real-time manner, and it makes sure that every SMS, every call, every data is accounted for as it happens. Now let's see an example on how this data looks like. I will take the MS-C data and show its corresponding OCS data. We find, for example, the position of the tower through which the call happened or passed through. We find the information about the source of the call, the country code, the operator name. We find also information about destination of this call and a lot of other information like the MC, the called party, the duration of the call, the MCSDN. There are some data that is only unique to MS-C, like the carrier of the call, the device used to make the call, the outrank, and there is also information unique to the OCS, which is like the balance. We can find the money or the amount deducted after a certain operation and what is left after it. So as you can see, we have complementary data from the elements in the core network and data from OCS. So to make sure that every event happening, like every call, every data, every SMS is built correctly, we need to compare the records from the intelligent network and from the core network. And for that, we need to build a reconciliation system between these elements. So how does reconciliation work? Actually, it's very straightforward. We start first by gathering data from both networks, from the records from the core and from the OCS from the intelligent network. Then we compare very carefully data from these both systems to see if there are any differences. Once we find these differences, we flag them so we can investigate even deeply and find the root of the problem. Once we find that, we fix it to prevent any further revenue leakage. Although the reconciliation itself seems very easy, actually it involves a lot of challenges, starting by the volume of the data, Telecom networks generate massive amount of data daily. To be able to process that very accurately requires the right tools and infrastructure. Adding to the volume of the data itself can be challenged, might be incorrect. The formats between both systems might be different and should be matched. Some data might be missing, corrupted, etc. So all of this adds another challenge. Reconciliation should be done in real time. And to do that, we have to do processing in a very high speed to make sure that everything is running smoothly. To handle these challenges, we turn to Spark from Apache. Spark was born in 2009 at one of the labs at Berkeley to handle the increasing need for big data processing. 4 years later, it was donated to the Apache Software Foundation, and it quickly becomes one of their top-level products. Since its release, it was adopted by industry's leaders like Netflix, and this is a proof of its capacity and power. So why Spark? What are the advantages of Spark? Actually, Spark has a lot of features and advantages that are hard to ignore. First of all, it's open source, which means that it is accessible, it is adaptable. It is built also for speed and scalability. So if you have small data or large data, Spark can handle it. Spark offers high-level APIs in the most popular programming languages like Java and Python, so which makes it developer-friendly. You can run it on your laptop, on the cloud, or using integrated system like Hadoop. You can connect Spark very seamlessly and easily with data sources like Amazon S3, Kafka, Elasticsearch. Spark can do batch processing or streaming, which is very appropriate to our needs for telecom operators. It can also run very challenging applications or advanced applications using machine learning and graph theory. So Spark, like in a nutshell, it's a powerhouse that offers very lot of advantages appropriate to our needs or to the needs of telecom operators. Let's now go to the demo where we will see other challenges not given by the infrastructure this time, but by the data itself. I will just switch to the demo now. I hope that you can see my screen.
Yes,
okay, thank you. So for the demo, we'll be using Python. So please don't be scared away. I will just explain the process itself, and we won't go deeply into the programming language. So if you want to run this demo by yourself, you need Apache Spark installed on your system. And here I'm showing how to access data from Elasticsearch. So maybe you will have to have the appropriate credentials to have this access. So we start by importing the right or the needed packages. So we use find Spark, which is essential to use Python with Spark. And then we start configuring Spark. To do that, we should specify the right packages to use. So here we are using Elasticsearch. So we have to use the appropriate Elasticsearch package with the right version. Then we connect or we specify the cluster we want to connect to, the port of the Elasticsearch. And here I'm just setting the username and password to the Elasticsearch I want to connect to. Once I'm done, I've done this, I will just specify the master. The master tells Spark where we want to run it. We can run it remotely on the server or on Hadoop, etc. Here I'm telling Spark that I want to use it locally, and what's between brackets here is to tell Spark that I want to use all the available workers on my laptop. Here I'm setting the configuration I presented before. Then I gave a name to my app. This helps me later to extract it if I want to do any changes or if I want to continue running it after it stopped. After that, I create the session. So now that Spark is configured, I can load my data. I will start by loading the MS-C data, which is available on Elasticsearch index. This is the index, and I'm just telling Spark to read from that index. So now my data is at this variable, all MS-C data. We can review or preview how our data looks like. So in the MS-C data, we have bunch of information. We have the timestamp of the event, the called party, the callee, the duration of the call, etc. Now that we have the MS-C data, I will go and load the OCS data. The OCS data is available at a different index. So I specify this index and I tell Spark to read it. And now it is at this variable, all OCS data. We can also preview this. And here we have also some information. Some is similar to the one we saw with the MS-C, and some of it is new. Sorry. So we have information about the timestamp, the called party and caller party as well, but we can have also information about how much duration was billed, etc. If you can see at the timestamp information, you can see that I have actually data from several months, March, April, June, and May, and maybe more. But here, for the sake of this demo, we will be using just data from a single day. I just choose a day randomly, and here I filter the data from this date. So I'm just telling Spark to take data only happening on the specified date. And here I put it in a new variable, MS-C data and OCS data. So I do the same for the OCS data. Here I'm just showing you a very nice idea or to do when you are working with Spark to persist your data using Parquet. So if you want to do some analysis with your data and it's very huge, it will be a good thing to save it as Parquet because it won't use a lot of your storage and it can be handled with Spark very easily because it is saved column-wise. So that I did before, so I'm just reading it again as a Parquet. So to make sure that everything runs more efficiently. So I keep the same variable. So my data from the day I choose is at MS-C and OCS data. What I can do also to improve the efficiency is to retain only the columns that I'm interested in. I'm not interested in all the information in the MS-C and OCS. So I'm selecting for the MSCS few columns and few other columns from the OCS. Now that we have loaded our data, I will show you some of the challenges that we find within this data and that they are not technical challenges. Some of this challenge is the lack of unique correlation ID. Sometimes you find that there is an ID that can connect or match or relate data from the MS-C and the OCS. But sometimes in some data, this ID actually is not it's not unique. It's our case here. So I'm just taking some reference, some ID. In our data, this ID is called network reference. So I'm choosing one just to show an example. So here we can see that for this network reference, it shows here. So for the same network reference, when we get it from the OCS, we find two records. These two records have two timestamps, two different cold parties and two different color parties. So for the same ID, we have two records. So it means that we cannot match this data using solely this information. We can combine it with other things like the timestamp, the cold party, the duration of the call, etc. Here, just to show you that I'm trying to extract the same records using the same reference from the MS-C, and you can see here, so here is the same network reference, and we can see both calls actually exist also on the MS-C. You can see that there is slight difference in duration. Like this one in the OCS, it shows the duration was 20 seconds, but in the MS-C it was 21 seconds. That's not really a big problem. So again, here I just want to say that sometimes there is no unique ID, and we should use a combination of fields to match the records from the OCS and MS-C. There is another challenge when we want to match data between OCS and MS-C, and that is the intermediate records in the MS-C. I will give you an example to understand it fully. So here I'm just taking another network reference, and I'm getting the data that it represents. In this case, luckily, it's just one record. So we have a call that happened at 5 between two different parties, and the duration of the call is actually 4,000 seconds, more than 4,000 seconds. If we pull the same network reference from the MS-C data, this time it's not a single record that it was extracted, but 3 records. But if we check carefully, we will find that actually it is the same cold party and the same color party. But what's the difference here is that the duration of the records is different than the one at OCS. So the MS-C data cannot record a call that is longer than half an hour. So when it surpasses half an hour, it will stop it, record it, and then continue recording. So here we have 3 records of the same call that was split. So if we do the matching, maybe the OCS will be matched with only one of these records. So what we should do before that, we should group this split records into a single one. So instead of having here 3 records, we should have a single one represented in our data, and we should sum this duration. So this is what I will be doing now. So I will take my MS-C data, I will group it by 3 different fields, because again, we don't have a single ID that we can match. So I'm choosing the caller party, the cold party, and network reference. And I'm telling Spark to take the minimum timestamp in these records as the timestamp to show. I'm telling it to sum the duration, and here I'm just keeping the service key because I want to use it later. So this is how my data will look like after. So my data now, or the MS-C data, is called grouped MS-C data. And you can see here we have an example that is more than half an hour, and that is recorded as a single one. So now what I will be doing once that I have grouped my data, my MS-C data, I will do data reconciliation. To do that, I will do left anti-join. So what does it mean? It means that it will find the records that exist in my MS-C but don't appear on the OCS. So I'm just joining the grouped MS-C data with the OCS. Here, I'm just making sure that the things are matched on 3 fields, the cold party, the caller party, and network reference on both data set should match, should be equal. And here I'm telling it to use left anti-join. Here is another trick to use with Spark. Spark allows you to create a temporary view if you want to do some analysis, like show your data, something that you just want to, you don't want to keep. You just want to analyze very quickly when you are developing something and you don't want to keep it like or to use it later in your program. So that's what I'm doing now. So I'm just using some temporary view to inspect my data. So here I'm using this temporary view. I call it analysis, and I'm telling Spark to use some SQL query to count the data that was not matched when I did reconciliation. And it shows that actually almost 2,900 records were not matched. It means that 2,900 calls were not billed properly. That's very huge, actually, for a single day. That's a lot of records unmatched. Now what we will do is we will analyze these records and see what they represent. So here I'm just showing this unmatched records, some of them. And if you can see here, for example, we have some call numbers that they have a different format than the others. They are shorter. Actually, these numbers, they might be emergency numbers or promotional numbers that actually they don't get charged. So you can make calls to these numbers for free. So it means that they won't never show on the OCS. We had to filter them before, but we didn't, actually, for the sake of this presentation. So when you are doing reconciliation, you have to filter these numbers first. And that's what I won't be doing it actually now. I just show some example of these numbers. So in our case, in our data, these numbers start with 2128. And here I'm just showing some of these examples. You can see that there's actually a lot of them with different durations. Next, what I will be doing, I will just count how many of these calls I have in my data set. So these calls actually consist more than half of my data set. So it means that it's really important to filter them beforehand. Another thing that we didn't consider actually in our reconciliation is the time difference between the MS-C records and the OCS records. And I'm showing an example here. So I'm just taking an example of a certain record. So it's the same record with the same cold party. You can check the same caller party, the same duration, etc. But when you check the timestamp, actually it's different. So at the OCS, the timestamp shows like 2 p.m., while the MS-C shows 4 p.m. as a timestamp. So we almost have 2 hours difference between these calls. So that's also a challenge, because what this means, because we are just taking a single day, it means that the first 2 hours at my MS-C data won't never show on the OCS, because they will appear in the OCS of the previous day. I can show you an example. So here I'm just counting how many records actually in the MS-C happens on the 2 first hours. That's almost 1,000 records. Here I'm just showing some examples of these records. So what I'm doing now, I will go to the OCS, all OCS data that includes the OCS of all dates and months, and I'm extracting the records from the previous day. And I'm just taking a single example here. So it's a record that happened at 11 p.m. with a duration of 14 seconds. If we go, okay, I'll just make sure I'm trying to understand what I've done here. Okay. Okay, sorry, here I'm not showing. I think I can do it. If my I hope that I can stop my session because I forgot to show this example. Oh, perfect. Okay. So here you can check that we have the same called party, the same caller party, but it shows on the 8th. So if we do the matching, when we did the matching, actually, this one didn't show, it was not matched. So it shows as unreconciled, while actually it was reconciled, but with data from the previous day. This is actually adds more challenges because I'm giving here another example. Again, from the previous day on the OCS, we find a call that is more than 2,900 seconds. And if we check the data of the MSC of the same day, we find that actually it was there, it was recorded, but with a different duration. Okay. Yes, okay. So here the duration of this call, actually it was 2000 seconds, but if you check here, okay, it's the same call, called party and called party, but on the MSC of the previous day, it was, we have just 14 seconds recorded. Because this call actually, it was split between both days. So it will show from the previous day that it was actually reconciled if you didn't check the duration, but on the other day we will have the other half of the call that it was not reconciled. I hope that you understood this point. It seems a bit complicated. Another challenge that we find is with the data is that there are some also records that does not pass through the OCS, taking, for example, the postpaid subscribers. This case, we won't have it on the OCS, but we will find it on the MSC. Here, the service key shows us the type of subscribers we have. Here we have two keys. Actually, 91 is for prepaid accounts and the null one is for postpaid. And when we check how many of these records we have, in our case, they were not many, they were just 5. So it's okay, but we still have to remove them from the unmatched records. Here I'm just showing these 5 records, and actually it's the same number that shows in our data, so the same caller or the same account. So now that we have seen these special cases, we have to remove them from our unmatched records. So what I will do, I will just take the unmatched records that are in my non-reconciled DF data. I will remove the numbers that are not charged, are free of charge. I will take I will consider only the hours that are above the first 2 hours of the day, because these are challenging. Actually, we should fix them more properly, but for the sake of this demo, I'm just showing a simple example. And then I will just take the prepaid cases. So when I do that, I am left with only 189 records that were unmatched instead of 2,900. But we can still analyze this data, maybe monitor it for fraud. What I will do now, I will just count among these records which one appears many times or several times as a caller. So I will get this data. It's called filtered DF. I will count for each caller party how many calls it made. And we can see that, for example, that this number, it made 12 calls and all these calls were unmatched. So this is a case to investigate. Is this account also free of charge and we didn't know? Or is it a case of fraud and he's using the system for free? If we check the records made with this number, we find that, okay, it doesn't appear at the OCS, but it does appear at the MSC. And if we check, actually, this number called the same account many times. So maybe this caller party is the one that is free and we didn't know. So this is also to investigate. What we can do also is we can check the called party. Maybe there is a party that is taking advantage of the system and may receive several calls for free. Or maybe it's a genuine account that we didn't know about, and that should be take calls free of charge. So I did that, and I found that one of them actually got 29 calls during that day for free. Another one, 17 calls, etc. So when we do reconciliation, we should make sure that we are not including any free numbers. We make sure that our OCS and SMS-C data, they are aligned in time. Otherwise, we'll have more challenges to match our data and reconcile it. And we should also make sure that we are not considering post-death. Here I'm just showing the records of this number and how many actually, what are the activity of this number during the day. So this is the end of my demo. I hope that it was a bit clear. This is just a last hint. When you run Spark, make sure to stop it, so to free all resources, and you can use them for other things. So to sum up, reconciliation is not a technical issue. It's more than that. It is a business challenge that can impact the reputation of a company, its compliance, its future investment. So this is a matter that should not be neglected by telecom operators. Hopefully, there are tools and infrastructure that can help the operators be ahead of the game. If you have, I will actually stop now. I hope that everything was clear. Now, Salwa, thank you.
There are two different scenarios. There are some operators that choose to manage postpaid subscriber also directly on OCS, that will charge the call, and by the end of the month send these record already charged to the offline billing and generate invoices. So in this case, yes, we will find the record in OCS and we will be able to reconcile them. So the other scenario is that postpaid subscriber for some reason, maybe license issue, or it's a choice to be able to manage them directly in the offline billing. And in this case, the mediation will collect CDR and filter only postpaid and send them to the offline billing system for rating and so on. So at the end of the billing cycle, they will generate the invoice. So yeah, if we collect also the CDR from the charging, the offline charging system, we can be able also to reconcile them like if they come from the OCS directly. But both of the scenarios are possible. Here the idea is just to reconcile the record that are shown by the CS and PS part of the network and the charging system. So either is it a pay-as-you-go or a bundle, we will reconcile record. Even a subscriber, if using a prepaid bundle, we will see record in OCS. We will see record debiting from free resources for prepaid. And the idea is to make sure that the record in MSC, SMS-C, or GGSN, especially the duration, the volume, are matched with the record generated by the OCS. So that's the idea. We in this reconciliation process, the matter is not to make sure that the bundle is charged correctly, or the process of debiting free resources from the bundle are executed correctly, but just reconciliating the core network with the charging at each record level. So the reconciliation process is running independently of the vendor structure of the data. So here, for example, for our demo, we process different vendor data files, and we store them in a lake house like Elasticsearch, where we have already a unified schema where we map all this data into a unified schema. So later it become more easy to scale or to run smoothly reconciliation process independently of the vendor. So it's a really data engineering issue. It's a kind of normalizing the data and map every field into the unified schema. We didn't work on a specific scenario that use voice over LTO, so maybe we will do some technical research, maybe to document this specific use case. If the question is subscribers that are not registered, means that the KYC, know your customer process, has not been executed for this subscriber correctly, but they are able to make outgoing calls. So here, in most of country, usually the SIM card is not allowed to make outgoing call if the KYC process has not been validated. But in some cases, in some countries, yes, we can find that subscribers are making outgoing call without being registered. So here again, it's a question of data engineering and being able to access to the KYC data. Here the idea is to get another data source where we can get for each MSESDN information related to KYC, or just a flag, true or false, is it KYC validated or not? And we can join this data with MSC and OCS data to enrich this data and filter on all outgoing call with a subscriber that is not KYC enforced, and we can get results. So yes, it is possible. It's just a question of having access to the KYC data and enrich CDR with information related to KYC data. And from there, you can query number that are making outgoing call without being KYC enforced. Usually the process when we create a subscriber on the HLR or HSS, we specify a specific template, and behind the template there is a decision that the template should trigger the IN or not. So if I create a number on HLR with a specific template ID that is, for example, pay-as-you-go or postpaid, and that will not trigger directly the OCS, yes, the number will be free to call in pay-as-you-go without having any traces on OCS. And this kind of issue, we can detect them by reconciliating subscriber database. Like, let's get, for example, a dump from the HLR for each subscriber, the template ID, is it prepaid, postpaid, and so on. And we get from the OCS the same information for each subscriber. the rate plan, the status, and we can, using exactly the same process, we can reconcile these two data set and get all the subscribers that exist on AHLL but does not exist on IN and the reverse. Yeah, it's possible. We showed how to do reconciliation at scale using Spark, especially for CDL, because it's a high scale and sometimes it's not easy to do it with the traditional tools. But for this specific reconciliation between AHLL and IN in terms of subscriber, yeah, it can be done by traditional tools, or it depends on the number of subscribers. Sometimes it's 8 million, 20 million, 30 million. It can be done easily with traditional tools. Yeah. If you feel that you still have more questions, we can keep in touch. Maybe share my email address, and you feel free, if you have any question, to share the answers.
Thank you everyone for joining us. See you in